Today, my talk actually is giving people a little bit of my point of view from learning computers for 34 years or more. Actually, doing operating system for 34 years, and I have my point of view, which may or may not be correct, but that's the ideas behind. Right. First of all. We start by saying why do we need this? What problems we're trying to solve? Basically, if you see the one problem we're going to tackle is that for smart homes, people should realize that from your phone to your home, actually you need something called a carrier. Because of there's no IP addresses in your home, there's someone behind the doors, behind the scenes, will find the connection. We'll get the connection going from your phone to your home. But since there are so many different brands, there's Apple, there's Samsung, there's Sharp, there's Huawei, but then they each use different carriers from your phone to your home. And there, of course, there's problems. First problem is the interoperability. Different vendors use different carriers. It's not like your phone, you always use China Mobile or use AT&T. You have so many different carriers from different countries, and how do they collaborate? And any one of those can literally steal your information for your home and broadcast your surveillance camera images to the internet. And also, if the carrier go bankrupt, then even though your devices are still good, but you no longer have the right to access your device. What we are providing is that we're building a open sourced, neutral, autonomous running carrier, which is the Elastos carrier. It's open sourced and powered by blockchain, so it's running in a way automatically powered by the miners. So giving people a neutral playground for all smart home device vendors. And so we do have a partner, IOEX, working with us because Elastos Foundation doesn't have a company. It's all open sourced, of course, sponsored by the Elastos tokens. But then we need companies to literally make those gadgets and sell them to markets. Because after all, you need a party to sign the liability supports and blah, blah. So that's why we're working with companies now. A second issue, of course, we're trying to tackle is a larger one, which is how do we build a new economy on this new decentralized internet? So this morning I gave a talk actually by May of 2016, Han Feng and I, we had some correspondence. I was saying, I don't know much about blockchain, but what we could contribute actually is a neutral smart home network, and also we could help build a smart economy. The smart economy meaning we could, operating system can do two things. One is in the past, you have a PC. When you log into a PC, you have a home directory, put your files. Now, could you imagine that you have a cloud drive, you put your data in, then you have different devices to access your cloud drive. So we are going to build the digital silos where the safeguards of your data. Otherwise, you have your data, but then if anyone is free to open up your data and send it anywhere, then you don't really have a protection. So the operating system job is to protect your home directory, your cloud drive-based home directory. That's the functionality number one. The functionality number two is that if you have a digital silo, I have a digital silo, then when I try to sell you something, not only for a token, I sell you an ebook. And someone literally has to do the logistics, have to ship your data from one place to another. And what if you're robbed on the way? What if you're cheated and rerouted your trade to somewhere else you don't know? And let's say you paid a Bitcoin for something, but then that something never delivers, right? You'll be sad, and there's no middleman to cry to. So you need that kind of guarantee that digital assets will be delivered to the right place at the right time. And on top of that, we're going to make sure when the goods is moved, is shipped, the owner of the goods will lose it, and the new owner will have it, right? To generate the scarcity and make sure the merchandise you got is worth something. Otherwise, if I ship you something, I still have a copy. It's a pirated copy, and it's hard to monetize out of piracy. So those are the two issues we're trying to tackle. But as I said, to make this logistic neutral and autonomous running, so we need the blockchain to power this carrier. We need the blockchain actually to protect your digital silos, because we don't want one company or one government protecting you, because we know actually it's not reliable. Then I'm going to give some ideas on what is a blockchain, because that's a very important question to ask. A lot of people ask about what is a blockchain, and they're trying to build like smart contracts. They're thinking it's a decentralized ledger, or it's people trying to build an operating system around a blockchain. Here's the 2 cents that I contribute. There's a guy called Alan Turing, who's supposedly the founding father of computer engineering, right? He was a British during the World War II, decipher Nazi code. And first of all, people have to realize that in the 30s and 40s, the computer science was really in its infancy. So people shouldn't be scared by the name Alan Turing when people say, oh, we are Turing complete. We are Turing something. Actually, it tried to be somebody, something. Actually, Turing is a really simple concept. For example, by that time in the 40s or early 50s, Turing came up with a experiment or called a Turing test. What's a Turing test? Turing test, see the bottom picture here, the bottom diagram. Turing test actually consists of 2 sealed off black telephone booths, so to speak, right? So you can, the C is a person, it's the judge, who could not see through the walls. The A and B, basically there are 2 booths. The black booth, it couldn't see through, but there's a little window. It's like a telephone booth or a ticketing booth. There's a little ticketing booth like this big, right? You basically hand in a note saying, hey, do this for me. Turing test was designed for artificial intelligence, saying, is a computer has intelligence? How going to evaluate that? What's the experiment guidelines to gauge whether you're saying the computer has intelligence? Actually, he designed this test saying, okay, there's a booth which has a computer in it. Then there's another booth, it has a human in it. Then you being the judge, looking at 2 black boxes, you handed a note saying, okay, what's the weather in Chiang Mai, for example? And so both parties give you an answer. Which one is the right answer, right? Then you're saying, oh, of course, if you hand a note to 2 booths saying, you know, what's the color of this flower? And of course, for a 1-year-old, right, the 1-year-old couldn't even speak. Basically, tell you nothing. So basically, what I'm saying is that a computer automatically of a 1-year-old intelligence. So if somebody brag about, okay, my computer is of 2-year-old intelligence, or 3 years of the dog's intelligence, basically it's saying nothing because of 2-year-old, right? What's the color of this picture? The 2-year-old, whether he knows or not, but he couldn't tell you. So, so when people doing that and saying, kind of in the 80s, the computer science stopped by like 5-year-old and couldn't go anything beyond. Because you cannot just say, oh, I can do 1 plus 1 equals to 2. That's more like 3-4 years old now. And so that's experiments designed for testing intelligence. But we borrow this test by, do an experiment saying one booth has a ledger managed by a single computer ledger, like a Bank of America or your PC doing the ledger, right? Ledger is a very simple thing. Basically, it's like writing a personal check. In the United States, you have one party giving another party account number, right? Party 1 giving to party 2 certain amount of money, and on which date, and signature of both, and it has a remark field saying, why should I give the money to you, right? What's the reason I give you the money? So that's a transaction, which really, really is, as I said, the ledger is just trail. And then I'll explain that. Of course, we have 2 booths. One is a blockchain-powered ledger. The other one is a single computer ledger by one computer, right? We know a computer, of course, like Bank of America can do a log of all the transactions of personal checks. And the blockchain can do the same. But to a judge, to the person C, can you tell the difference, right, of the 2? You basically cash a check with party 1, and you cash a check with party 2. And the person C can only see the difference is that, of course, the one by the blockchain is slower than the one by Bank of America, for example. Secondly, throughout the years, he realized, okay, actually there's one booth that's more reliable, more trustworthy, because he's not going to cancel your account or somehow accidentally lost some of your transactions. So person C basically feels one ledger he could trust more, correct? He could trust more, but then they are both ledgers, correct? And whether the Bank of America ledger is sponsored by some big corporation, big bank, or the other one actually is powered by 10,000 nodes, miners, actually the person C doesn't really know, doesn't really care even, right? And as for every 10 minutes, there's a reward of 12.5 Bitcoins. That's really none of person C's business. It's a way of incentivize whatever's inside one of the booths. That's your internal business, okay? So really the way to incentivize the miners, that's an internal business, and has nothing to do with us. So a lot of people want to invest into cryptos, attending seminars, and trying to study hard to do the duty on themselves. My advice give you is that the more meetups you go, actually the likelihood of being cheated upon actually is greater, because you're not a computer science. Why should you care about the mining algorithms? Actually, mining algorithms like what's a nonce, what's a hash, what's a bitmain, really has nothing to do with consumers. As if, the Bank of America bank, do you think that's just one computer? Alibaba has hundreds of thousands of computers behind the scenes, right? It's not a computer. But how many people bothered by, I have to know the inner workings of Alibaba, or I have to know the cloud computing infrastructure of Amazon? And people simply chose to hack. That's Amazon's business. I shouldn't care, right? Because computers has been around for since 1946. It's been 70 years. Then we don't care anymore. We don't have to. We don't have the curiosity to look into computers anymore. What I'm saying is, why should we have a curiosity to learn about blockchains? The more you learn about blockchains, the easier you got cheated. That's my conclusion. And to the outside, or the person C cares what kind of functionalities you provide, okay? And even though, of course, he finds out, first of all, one is more reliable than the other. So the one with the blockchain powered, gaining his trust more. The trust is what the blockchain is building. What I'm trying to, there I say the ledger is a drill. Like, there's stories, right? There's a big enterprise, I forgot which, and then the founder of this enterprise getting old, but he has a passion attached to his enterprise. So he was just doing gardening on the yard, and some newbie interviewee comes, and so anyway, he behaves good, behaves bad, and then turned out, you know, the gardener was the founder, right? So basically, what I'm saying is, gardening is it's an experiment. You can test a integrity of the newbie, whether this guy is a decent, you know, respectable person or not. Whether you use a ledger to test, or you use gardening to test, or you use some other means to test a person. You just test the person to see if he can gain your trust. The experiment doesn't really matter that much, right? So whether we're using a ledger to build a trust, or we use something else to build a trust, the ledger itself is really, really not important. That's what I'm saying. Now you can think of that booth as if it's a service booth. It's a census bureau that gives everybody an ID, right? Booth A gives you ID by a Census Bureau of China. And booth B, being the Census Bureau based on the blockchain, gives you IDs. Then a government Census Bureau may make a mistake, and then the blockchain Census Bureau may not easily manipulate it, correct? So in a way, that booth is also, we call it in software, call it a service, which is a black box, sealed off, providing you some services, say Census Bureau. To see anything outside the booth, actually we are it's the internet. So blockchain has something called on-chain, off-chain. The common denominator of all the off-chains actually is the internet. So we use blockchain to issue us IDs, which is not controlled by single company. So the ID is not issued by Google. The ID is not issued by Amazon. The ID is issued by blockchain, so that no one can revoke your ID, right? And also we can use blockchain as a notary public service. So every time you make a short video or write an ebook, you take a hash. You know, if you use Windows 10, right-click on the file, actually there's an option. You generate the hash for your file. It's pretty simple. And you have the hash, you register to the blockchain, so to prove on certain date, you are the original author of that piece of video. So in case someone parodied your video, you can prove it to the judge. You are the original author, right? Because you have the hash recorded on this date. The parody person may not have that hash earlier than you, so you are the original author of it. So you can think of that booth is a notary public. The third service that the booth can provide you is something called a Commerce Bureau. If you think of a government, right, has a Census Bureau, has a notary public, or has a Commerce Bureau. What Commerce Bureau is, every merchandise literally requires a barcode. Basically, you produce 10,000 autonomous driving vehicles. Because recently we went to Suzhou. In China, we visited this new energy, the battery-driven sports car. So literally every vehicle produced actually require a government-issued sticker. So the Commerce Bureau gives them 10,000 stickers, no more, no less, correspond to 10,000 electronic vehicles, right? And to sell on the market. So basically what I'm saying is the blockchain can give us the stickers, virtual stickers for our merchandise on the internet to create something called a scarcity, right? Because if you have infinite number of ebooks, then it's not worth much. If you have only 10,000 copies in circulation on the internet, then it's worth, it's a digital asset of yours. So that blockchain-powered booth, right, can providing the three mentioned services. Can that booth providing you the ledgering service, the accounting service? Actually, in my mind, which is definitely not one of the services blockchain is good for. Because even though it's a ledgering, doing cash transactions, but it's so slow. There's no way it can compete with the Bank of America's computer, right? If we rely on that blockchain computer to give us the speed of transactions, say Alibaba, Alipay, or Apple Pay, definitely couldn't keep up. Then why bother use a blockchain to be the Alipay? Because that's not that blockchain's good for. So what I'm saying is blockchain is Census Bureau, a notary public, the Commerce Bureau, but it's not a database. It's not a ledgering service. That's the key, right? And also blockchain, on top diagram, the blockchain is a computer. And it's not a general purpose computer. If anybody trying to compare this blockchain computer with the 1946 ENIAC general purpose computing of the world, I think it's mistaken. Again, by Alan Turing, what computer is computer consists of two things. One is computer consists of mass storage, permanent storage, which is a hard drive. And computer consists of a computation unit, right? Where the CPU basically. You have a storage, you have a CPU. Then that's a computer, according to Alan Turing's Turing machine paradigm. But if you look at the blockchain, does it really have storage? It has a ledger, but then the ledger is only for store hash. Let's say in 10 years of Bitcoin running, we have about 160 gigabytes of data. If you put movies, you put books stored on the blockchain computer, simply it's full of garbage. And if you have 10,000 nodes sync off all the garbage, it's impossible. So that blockchain computer does not really have infinite storage, doesn't really have a hard drive. It has a little bit built-in storage only for hash. And also, does that blockchain computer has a CPU, general purpose CPU to run your office, run your gaming? It's not that designed for. It has some CPU capability to generate nonce, to do the hash. So that's why I call blockchain a specialized computer, which is really, really not good for running dApps. What's a dApp? dApp is what consumer uses. So those fundamental concepts are, I'm not saying everybody else is wrong. I'm really the wrong, okay? But I dare to differ. And I say that blockchain is really not a general purpose computer. It cannot do dApps. And what dApps is running, actually we see inside the booth and outside the booth. Outside booth actually is the network, it's the internet. That's where the applications happen, right? Given trust on the internet, how much we can do. Trust itself is nothing, cannot do anything. We need trust to do more business, right? Trust itself is not doing business. That's completely two different concepts. When people are misunderstanding that trust itself is business, which is definitely not. Then we're going back to the beginning of time. When I started the Elastos project in year 2000, this diagram actually I drew in 2002 when I named it Elastos. Basically, Elastos from this diagram, actually this diagram originally, I mean similar one of those, the yellow one, actually is drawn by someone called Van Neumann. Van Neumann was the first computer's lead, the manager of the first computer, the team who generated the first computer, who made at the University of Pennsylvania, the ENIAC. Actually, by that time, he wrote he drew the yellow part. Basically, you want the computer to be as fast as CPU, the storage as vast as the hard drive. So when we say Elastos computer, actually, literally, we mean it's a cloud drive-based computer mechanism. That's all. And secondly, this is also another diagram I drew, in 2002, because of with the realization that the first web was a web of so-called data, the web of information. So with that click, you get your web pages, and that impacted the world. Then can you imagine, right? Now with one click, not only you get data, you can also get code. Very simple comparison, but then I believe the impact of this latter is greater than the first one. And then this another diagram I drew 16 years ago was you own your own data. The idea was that Windows has 26 drives, A, B, C, D, E, F, G, at most 26. Then can you replace that single letter with a domain name like Microsoft.com, Tsinghua.edu? Then literally you can have infinite number of hard drives. If you treat the internet as a computer, then you need to have a home directory. So you have that many, like 5 billion home drives for this internet computer. So that's the model we're building upon. So we're building the internet as a computer, then everyone has its own storage. And another concept I want to emphasize a little bit, as I said, the blockchain is really the little mechanism to build trust. It's not for computing. In comparison, we all know this phone has a fingerprint reader. Actually, fingerprint reader itself is a computer because of what it's good for. It's pretty fast, right? If I put my finger in it, it'll recognize and open up my PC, my phone. But then this computer literally is not the computer we run iPhone apps running on the main computer. Basically, this comparison is saying that the blockchain is the fingerprint reader. It's the trust builder mechanism for this internet, right? The internet is where the CPUs are, and the blockchain is where we put trust. Then we're talking about Elastos. In addition to the blockchain that building the trust, the Commerce Bureau giving us stickers for our ebooks, for our movies, for our games. Then every time you run it, right, you have to make sure if you sell me the book, you cannot run it anymore. So then we need a guarantee from the execution environment. We call it a virtual machine OS. And then also, when you deliver this digital contents from phone to phone, you want to make sure it's encrypted so no one can parse your work in the middle. So that kind of thing, you need to have this so-called end-to-end guarantee. You have two virtual machines running and end-to-end encrypted. You send it through this single tunnel. And then any phone cannot steal your information and send it to the author of the software. That's three parties. One is the consumer. The other one is the computer. And the third-party software is the app. Currently, the old operating system, the app, could literally open up your Word document and in theory, could couple it to the author of, right, the manufacturer of the software instead of the original owner of the consumer. So that's, again, that's the model. Without this guarantee, the virtual digital economy simply cannot exist. If you compare to other blockchain projects, a lot of them saying, okay, now we can keep track of the provenance of this artwork. We know, okay, we have 10,000 stickers and you own one of them. But if they cannot prevent piracy, basically they cannot build the economy. Those are the ideas behind Elastos, right? And this is the model for a modern so-called Elastos computer. Because the old computers, when I was in school, all the peripherals are so-called a dummy. They're all basically dummy, meaning the peripheral without CPUs. And if a printer doesn't have a CPU, and what drives the printer to print A, B, C, D? Actually, it's a piece of software run on the motherboard called a device driver, right? So we still have a device driver. You know what? The device driver idea came from Unix, which is designed in the 1970s. And also, it's early 1970s. Actually, it was designed, start designing of Unix in 1970, 7-0. The modern internet, the internet we know, actually started the design of internet in 1969. So literally, we are using the infrastructure half a century old. It's that old. Really, can we think of something new now? Because now every CPU, a CPU costs less than $1. So literally all peripherals now are smart. All terminals are now smart. Used to be dummy terminals. Now they're all smart. Given that in mind, can we design something more abstract, software-defined, right? They're still called peripherals. They have a CPU. The reason why they're called peripherals is because they cannot directly access the internet. Otherwise, there are too many sensors. They are too easy to launch DDoS attacks. So we need to assign each CPU a role they play, even though they are all actually computers. But some computers play the role of a terminal, like your phone. Sometimes it plays a role of a display, or it plays a role of a server, right? So kind of very abstract, but then we don't want to go to details, but that's the model we're building. Here's we're going into a little bit more in-depth, dive in. What's that personal cloud computer? If you see, according to Alan Turing, a computer consists of a hard drive and a bunch of CPUs. And if you see, could we use a cloud drive being your hard drive? And could we use the CPU of Amazon computer being one of the CPUs? And your phone has another CPU, and the third CPU is actually in your routers in your home. Can you have that kind of multiple CPUs and with your cloud drive base? That's your personal cloud computer. That's the digital silo we are building. So everyone has several digital silos, right? One for work, one for home, right? One for your social activities. So you can build several computers for yourself, and also you talk to one another through peer-to-peer. Everyone has a personal cloud computer, then we talk to one another through this decentralized carrier, the carrier that has no company behind. It's an AT&T without AT&T, so to speak, right? So that's what we're building. We're building two things. We're building this virtual computer, then we're building the carrier, autonomous running carrier between computers. And why we need a blockchain? It's because of we need something like this, right, to build a network computer, and very abstract, but then now I'm going to explain a little bit what is a Elastos app. Elastos literally has three kinds of apps. One is we call them the web app, Elastos web app, which is really the web app like Chrome, like Internet Explorer. Because the web without HTTP, the web that utilize or leverage the decentralized carrier, because we don't want the browser or plugin to get your data and send to somewhere you don't want to. So we have to have that guarantee. Then that's where the bottom here, the Elastos peer-to-peer network has to replace the HTTP. And the other one is we want to use the DID instead of application ID logins, because when you have a mobile app, how many different passwords you have to remember, right? Can you have a decentralized ID with your fingerprint and your facial recognition, and on the phone you just sort of stare at it, you can log into your D app, right, without having to worry about your password, your login IDs, and those things can come naturally. Like today in China, literally you can scan your passport, and you with the fingerprint and the facial recognition, you can enter a country or go out of the country by yourself, right? Because auto customs. So in a way, Elastos browser is the entrance point to this Cyber Republic and out. And the second kind of app, we call them peer-to-peer apps, because peer-to-peer is like we all know P2P network. P2P network is like a phone, right? Because you have a carrier, that's one phone to another phone, that's a peer-to-peer network. And then the old phone is dummy. Now we have smartphones now. So smartphone can do compute, can run programs. So we call them peer-to-peer compute. Basically the programs running inside phones, peer-to-peer, and without having to worry about this carrier. That kind of paradigm is like a decentralized telegram. No one can purge your information, right? And that's very powerful because of, think about it, we're doing a carrier without AT&T or without China Mobile for that matter. So it's an autonomous running carrier. So then giving you an illusion that you are playing a chess with your some party remotely, right? Peer-to-peer, you can play chess, you can send money, you can do chat, you can do all social networks, right? Peer-to-peer without worrying about there's a middleman and eardropping on your messages. The third kind of apps is because we do have peer-to-peer, then can we bet on a football game? Or can we use the money to buy something, to do a transaction? For example, if I want to buy something from the United States, from China, then the goods literally ship across the ocean, takes days. Then should I pay money first, or should I, you deliver the merchandise first, right? So you need a middleman there. So, but then if you want to do it peer-to-peer without middleman, then what can you do? So we have the carrier running. So the carrier is running autonomously and decentralized carrier. Then it can launch a set chain on your behalf for this transaction and run some smart contracts on the set chain. So then we have a team right now porting Ethereum EVM on top of Elastos set chains. We have another team right now porting Neo smart contracts onto Elastos set chains, hoping by the end of the year when we ship beta, we should be able to have some simple demos that you're betting a game or you're shipping something, then there's a smart contract launched on your behalf and to be the middleman. That's why I was saying that Cyber Republic, actually, we're voting actually blockchain robot being our president, right? So then if we want to bet a game peer-to-peer, actually we are, instead of a human middleman, actually we are literally generating a virtual machine be our middleman for a shorter period of time during our business transactions. That's the model we're building. So that kind of, with the Elastos sidechain being, running the smart contract, being the blockchain robot middleman, That's the third kind of apps, the Elastos dApps. It's not Ethereum dApps because we have 3 parties involved. One is running on your phone. The other one is on the other party's phone. And the third one actually is randomly popping some virtual machine on the carrier. So it's not, in the carrier may not be one of the mining nodes. It's just some random nodes in Amazon or in the Alibaba or SoftBank. If you don't trust one virtual machine, you can launch 3 nodes, 21 nodes, right? Nevertheless, you never want to run 10,000 nodes on a football game betting. That's a wasting of energy, then it's completely wrong paradigm you're trying to compare with. So that's why I don't agree with Ethereum's public chain running smart contracts. And this is on top, somebody using a phone to buy a Coke. That's actually the story I made up 2001, literally 17 years ago, when I founded the company. And people are asking me, what's Elastos for? I was saying, in the future, Elastos should be enabling you use your phone, go to a vending machine and buy a Coke. I don't know what I was talking about 17 years ago, but I talked about it because in the audience there's Chen, she was there, right, when I was telling the story, and her husband was there as well 17 years ago to listen to the story I didn't know. Then the reason why I have, on the left here, that's the, as I said, the robot middlemen. There are multiple robot middlemen. It's not a single robot middleman. It's many middlemen, right? And on the right, the reason why I draw that many carriers because of network as a computer. Literally, you could have multiple network computers. So that's why I have the multiple network computers on the right and multiple blockchains on the left, because that's one blockchain is one computer. Literally, the Elastos is a network of computers, so you can have different kinds of blockchain computers running. You can have different network computers running in parallel at the same time. Without this understanding, if you try to build one computer and to run all apps on one blockchain, I'm pretty sure that's definitely a mistake to be made. Another thing I mentioned is just, the whole reason, actually, not only for security, but it's also given a secure environment. Actually, we want to encourage more business. And people are asking, how does the Elastos Foundation make money? First of all, Elastos is not a company. It doesn't have to make money because of we do have the tokens pre-mined. We do have the inflations, portion of the inflation given to sponsor the core team to maintain the roads, the infrastructure of the new internet. And secondly, for those services like DMA, decentralized marketing, the reason why we have decentralized marketing is you own your own data, but do you know how to sell your data, right? So that's why we need decentralized marketing. We need a decentralized exchange. We need search, decentralized search, right? If Han Feng wrote a book, and then let's say search for blockchain books, if Mr. Feng Han wants his book to be ranked among the top, he has to pay some ELAs, right? And then the proceeds, ELA, Elastos Foundation doesn't have a cloud drive. The Elastos Foundation doesn't have a wallet. So the proceeds will not go to the Elastos Foundation. The proceeds will be dispatched by smart contracts to reward the hard drive providers, the IPFS maintainers, right? And to give it to the marketers, given to the distributors, developers. So they're all like Han Feng paying for, let's say, one ELA for to be ranked higher, right, than my book, for example. Then this one ELA will just automatically, by proportion, divided into different wallets, because, as I said, the Elastos Foundation doesn't have a wallet. But then a portion of it will go to the developers of the search engine. It doesn't mean, Elastos Foundation doesn't have a company. It doesn't mean the teams like IOEX, ViewChain, and IPFS, and search algorithms, DMAs, they all have companies, right? So the development may need some small portion, let's say 1% going to the search engine developer. But then, of course, we encourage there's another search engine which may willing to take 0.5% in their smart contract. Then it's the consumer's choice which search engine you want to use. But nevertheless, Elastos Foundation doesn't have a wallet to receive any of the proceeds. Some of the Elastos Foundation team members may have two hats, right? One hat is they're working, contribute code to the foundation. They have another hat actually working for a small company doing one of the services. That's why we have this Elastos Carrier, Elastos Runtime, Elastos Blockchain, and then now we're having Elastos Services, right? The services, actually developers. Services meaning swappable, replaceable, but then they do require certain dividends or certain payments there. So that's how the engineers got paid. Those are some history. I'll flip through quickly because I wanted the team to update those pictures. Those are the pictures I got 2016 when we were working with Foxconn and making those hardware. So those are the different pieces were made 2016, 2015. And here I talk a little bit about programming of Elastos. People are asking me why we use C++ to build Elastos. Because of, we thought about Java, because Java is a virtual machine, but Java has two fundamental problems or shortcomings. One is Java, even though it's Turing complete, it can run programs, but it cannot run 100% of the programs. I want to emphasize here is a lot of blockchain projects are bragged about. They are being Turing complete. I think that's an overstatement. It's true, but they are trying to mislead investors. When you say it's Turing complete, in theory, it says this mechanism can run all programs. But then given the conditions, prerequisites, Alan Turing was saying that a Turing computer is infinitely fast. And Turing computer has infinite storage. And Turing computer never makes mistakes. That three statements is really, really, overwhelming, right? Is their computer infinitely fast? Is their computer got infinite storage? Is their a computer which never make mistakes? None. So that's, in theory, that's the, if we do the derivatives, if we do the calculus in college, right? That's the unlimited. Basically, that's infinity and beyond. But then, in reality, nobody really is Turing equivalent in real world. So any blockchain projects brag about their Turing complete. They want to cheat your money, be aware. Okay? And say, Java, definitely faster than JavaScript, but still it's not as fast as CPU. So when you run Java, you cannot do 100% of the programs because Java cannot do game engine, cannot do deep learning algorithms, cannot do multimedia codecs. So for those tasks, you need to directly go to Linux, go to the CPU. So Java intentionally left a backdoor called a JNI, Java Native Interface. Then if you have a backdoor open to all developers, literally you might as well have no VM, no sandboxing, because the backdoor is wide open. Then you're saying, okay, I have a sandbox. What are you talking about, right? You have so big a leaking bottom, then you're saying you have a sandbox. That's a joke. And secondly, when Java has something called a metadata, it's a dot class, the reflection information, but then Java did not leverage that to do the so-called end-to-end computing because you literally need the Java virtual machine on one machine, on your phone, on the client, and you need Java virtual machine in the server, and having two Java virtual machines generating network packets so that they cannot steal customer data and send it somewhere else. That's very, very important to realize. That's the end-to-end encryption. But in Java at that time, they didn't really have time to build an end-to-end solution, and Java went under and being bought by Oracle. And Oracle has no intention to make it any further. So, but then now if you look at the new technology like Windows 10 or Elastos, between languages, between virtual machines, all traffics are auto-generated. So we don't allow GNS anymore. We don't allow and we encourage end-to-end encryption. That's the model, and some of the apps we built during Foxconn years, but I hope people are updating it with the alpha logos, alpha icons. And just showing some code snippets or just saying, you know, it's working, and there's more demos coming up. The machine got stuck. Okay, now I'm pretty much done, and next for demos.
Any questions? Because I was told there isn't going to be a demo. We're just going to go straight to the ecosystem projects. But we will allow some time for Q&A with Rong's presentation just now. So if you've got any questions, please put your hand up, and then we will give you the microphone. Any questions? Yeah. For Rong? Or shall we asking a bit? Is there a question? You're going to speak in Chinese or English?
English is fine.
So you're saying that instead of using so-called DApp running on all of the computers around so-called blockchain, Elastos DApp can literally run as a native app that runs really fast. Is that basically what you're saying?
Well, Elastos runtime is a native runtime. It's a native virtual machine. Basically, a virtual machine is not that hard to imagine. It's just like a Unix process. If you think of DOS of 30, 40 years ago, right? The DOS meaning a disk operating system. Basically, at that time, it's not multitasking. It's just a single address space with a hard drive. That's equivalent to a Turing machine. And so that's a machine. And so long as you have a hard drive and you have a CPU, then you're a virtual machine. So what I'm saying is Unix process actually is a sandbox. But then the Unix runtime lets you access TCP/IPs yourself. But Elastos runtime won't let you access TCP/IP. So, and also we give you, when you log in with your finger, it will launch that process on your behalf with your DID. And also through the DID, we find out where's your cloud drive. Then we only set up the channel from the CPU to your cloud drive. So in theory, because that's a little bit abstract, what I'm saying is in the future, you can imagine you got a phone, but right now it's my iPhone, so I put my finger, and basically it's entering my environment, right? So in the future, you can imagine if the network is fast enough, anybody getting the very phone, my phone, right? Just if I hand it to you, you put your finger in there, then your environment launches right away. So that's the model we're building. But of course, it's because of network latencies, it's not coming to reality anytime soon. But that's definitely a different computation model. Anybody. So because over lunch we're talking about we're in Thailand, you know, the Thailand folks, they're sincere believers of Buddhism. If you go out to the temples and you see the people always like this, right? That's the gesture from Buddhism. And the Buddhists believe in reincarnations. And the reincarnation meaning basically your body is like a phone. In a few years, it's getting too old. right, and die. So you get a new phone. But your spirit, your genie, right, lives on through incarnations. So what I'm saying is the virtual machine is the genie. It's the incarnation of yours. And it goes through the different phones. Then, so if your finger touch the phone, actually your genie goes into this lantern, right? That's the model we're building.
Thank you. Another question? Anybody? Sorry, I'm not really looking straight. This one? Which one?
Yeah,
This
yeah.
one? Okay, the next. Oh, sorry, have I got it?
Or, okay.
Have we lost?
Rong, a very interesting lecture. I actually read through the slides a few times. I really enjoyed it. On the scalability of the blockchain ecosystem, we used to see platforms led by Ethereum. The young genius Vitalik was proposing lumping a lot of things on the public chain. We see a tide changing, like the new breed, like Nervous, and also Xiaofeng's platform. They try to use a layered approach. I view that, I think there are similarities between the layered approach in Elastos. You guys have the carriers, and that does the P2P network, and then you have the blockchain, who does the DID, the trust, things like that. You have the right amount of division work. Do you see the solutions for blockchain scalability going in that direction, going in the kind of years experience in the OS into the layered approach, do the divide and conquer, that kind of thing?
Yeah, Frank is asking that actually there are many public chain projects now are moving towards the Elastos direction. Talking about building an ecosystem and some similar concepts, right? And whether, he was just asking whether it's possible to stretch out the, expand the blockchain capability and to support this kind of paradigm. In my opinion, no, they cannot. Because I said, it's very clear in my mind, each person has their own computer, their own cloud computer hosts their own data, right? You own your own data, actually your own data saved in your own cloud computer. So there are many cloud computers belong to different individuals. That's very, very clear. It's not a single computer. As I said, there's no infinite powerful computer can support all humans at the same time. Right? No single computer could do that, because if you say Cray computer, supercomputer is super fast, by my pocket, simply it's not big enough for a Cray computer, right? Because I only run a cell phone because it's cold enough to put in my pocket. And so which is a one computer versus network of computers, right? The reason why we need a carrier is because we realize that everyone is entitled to have their own cloud computers, then we need a carrier and autonomous running, decentralized carrier to connect all the computers. That's very, very clear, 2 dimensions. The computer is this dimension, the carrier is this dimension, and powered by the blockchain to issue IDs to make them autonomous running without AT&T, without China Mobile. That kind of concept is crystal clear. I don't know which else blockchain project has this kind of distinction. So very, very sharp, right? 90 degrees perpendicular, orthogonal to one another. If you don't have this kind of vision, and also given this computer and the framework, the loosely coupled framework has to go mainstream. You have to support Java. You have to support like Android-like loosely coupled framework across machines, building services that literally takes millions, tens of millions of code. Even if you realize that's the story, how much time do you need? That's a lot of work there. Engineering-wise, I mean, as far as I see, right? It's some people ask me whether you're afraid, somebody, big corporation, huge enterprises copy Elastos code. First of all, if they're huge enterprises, they have their reputation on the line. If they copy all the code, right? I mean, I know in the United States, it's not possible, right? Microsoft could literally crash Netscape, but they're there too. They do that, right? Like when Facebook was only 20 folks, could Apple crash Facebook? I mean, not in the United States. I'm not sure about China though. But then the thing is, why? Because it's all free, it's all open source. Why don't they just come to join us to build a safer internet for all? Why do they want to copy our code, right? And secondly, for those small startups, maybe they want to, like a blockchain project, how many of them copy someone else's code? A lot of them. But as for Elastos, if they copy like 10 million lines of code, do they know where the bugs are? Which is the priority? Where are you going to build the pillars, right? There's no way for a startup just to realize this much. So I'm not free to have anyone to copy us.
Thank you. One more question? One more question here.
In your earlier speech, or Han Feng said that Chinese government might use Elastos in some application area that could potentially become a kind of governance infrastructure. What's more detail about that? Can we hear some more detail about that?
Well, since we have been, Elastos project has been in China for 18 years, definitely we have our connections to the business, to the government. Because for a better, cleaner government, actually it's everybody's hope, right? So it's really nothing about Chinese government versus US government or like British government. That's not matter that much because we're 100% open sourced, we're neutral, and autonomous running, right? We encourage all governments and all corporations to contribute to the republic.
Thank you.
Yeah, Rebecca, you want to do some?